today we're solving quadratic inequations. So an inequation is when we have this symbol, those symbols here in our equation instead of the equal sign. And this one here, when it says solve, when is x squared plus x minus 12, when is that greater than 0? So what that means is when is this graph above the y equals 0 line. So above the y equals 0 line. So if I was talking about the graph, it's like when is it, when if I had, so if that was the example of the quadratic or whatever, we're talking about when is it above the y equals 0 line, which is that. So when is it above here? Okay, so the first step in solving an inequation is to rewrite the inequation as an equation with an equal sign and solve that equation. So we know when we have a quadratic and we solve it, we've got to factorize it. So factors of x squared are x, and factors of negative 12 is negative 3 and negative 4. Oh, sorry, positive 4. So if I test that out, x times negative 3 is negative 3x, and x times positive 4 is 4x, and they add to give that number. Okay, so I can factorize it to x minus 3, x plus 4 equals 0. So if I was solving for x could equal 3, or x could equal negative 4. Okay, so the second step is to sketch the quadratic of the graph. So if I was sketching this roughly, and so we've just found the x-intercepts, so we know that this one is at 3, so we have 3 and 0, and this one is at negative 4 and comma 0. So we've got the x-intercepts. So we are trying, because of the this graph was when is it greater than 0. So that's going to be these bits here. So that's when it's above the y equals 0. So this line is y equals 0 along there. Okay, so we want it above. So that's the last step. So the last step is to determine, so you use the graph to determine when the values, or for the values of x, x for which x squared plus x minus 12 is greater than 0. So in this question, because it's greater, we're going above. From the graph, we can see that the quadratic is greater than 0 when x is either larger than 3 or when, so that bit here, or when x is less than negative 4. Now we could write it like this, or sometimes you'll see your answer written in a little bit of set notation. So they like to put the little brackets, and they'll say when can this formula be, or this quadratic inequation, when is it greater than 0? And they might write it like that, and you can write it in return and say when x is either less than negative 4 in union with, so that means also when x is greater than 3. So I'm happy for you to write your answer like this, but we just might need to be aware that, you know, in a multi-choice they might use a little bit of this language, or in an exam. So just be aware of that. So I'll do another example on the next page. Okay, so solve the following inequality. So because we already have it factorized, we don't have to factorize it. We can just solve for x. So we know if the null factor law, x could equal 6 over 2, which x equals 3. Or rearranging this one, x could equal 4 over 2, or x equals 2. So we've got our two x intercepts there. So if I went to sketch this graph, now we do have to have a think about which way the graph is going. Like, I mean, is it a positive or a negative? If you times that out, I'd get 4x squared. So that's a positive graph. So I know which way the graph's going. So the graph is going upwards. So here are my, my graph, because my intercepts, so it looks something like this, sorry. So I've got two intercepts, and I have one on 3, 0, and the other one on 2, 0. So if we look at the inequality sign in this one, we're asking it, when is it less than 0? Then the y, less than y equals 0. So remember, y equals 0 is this line. This is y equals 0. So when is it less? It's down here. So the part of the graph that is less than 0 is this part here. And when we have that, so that is somewhere, anywhere between when x equals 2, anywhere up to when x equals 3, that graph is under. So for this, when we're writing the answer for this, so 2x minus 6, 2x minus 4, when is this one less than 0? Well, we write when, now x is in between 2 or 3. Okay, so when you have that curly bit, the curved bit, your answer will look like this. Now, also note too, my inequalities are just less than or like that because there's no equal sign on this one either. So you just keep them the same. Okay, so with this example, we've got, it's already factorized. So if I find the x intercepts, I'll let these factors equal 0. So I get x is 6 over 2, so x equals 3 is one answer. Or, or otherwise, this one's the same, x equals 3, so 2 factors. So if we go to sketch this, but remember we have to know whether it's a positive or negative. Now, if you, when you were timesing this out, if you times this graph out, you would get negative 2x squared. So that is a negative graph. So because it's a negative graph, it's going to go upside down. And it's got an intercept on 3. So here's our 3, 0. So it's going like that. So for this one, when it's asking us, when is the graph greater than or equal to 0? So that's talking about when is it greater than or equal to 0. So really the only time that this graph touches is on that one point. So the actual answer for this one is 2x squared 6, 3 minus x. When is this greater than 0? Well, only when x equals 3. And that was just one example. But just be really careful whether your graph is a positive or negative. You should check that. It's harder when they're giving you the factors. You need to double check that it wasn't a negative graph. Okay, cool.